a fairly common newish style linear LED strip light. This one is by the brand VTAC Innovative LED Lighting, and the most interesting about this is it says LED provided by Samsung, which does inspire confidence. Now this is quite a long unit. The reason for that is I got it with a view to using it to augment the lighting at the other bench through in the other room, or the other studio you might say. The length of this fixture is 600mm, which is about 2 feet. It comes with a 5-year warranty. I don't know whether that's going to... Having said that, this came from CPC in the UK. I've mentioned CPC recently for another product. It's not sponsored by them. It's just things I've been buying from that company recently. So it comes in 3 temperatures, colour temperatures: 3000K, which is a warm light; 4000K, which is a medium light, which an average sort of white, which is what I've chosen here; and 6400K, which is the harsh cold white, the sort of bluey white. Claims on-off 15,000 times, cycles, lifespan 30,000 hours, colour rendering index of 80, greater than 80, and power factor of greater than 0.5, which isn't great. Material plastic, it feels very light. Main features are, product features: ballaster starter not required, direct AC power, perfectly matches the traditional daylight tube fixture, easy installation, no flickering, no UV radiation, long lifespan, low maintenance, energy saving, 0 to 100% in 1 second. Then it gives loads of suggestions and says it comes with quick connector, protection rating IP20, and it does come with loads of photometric type data, which is useful. Let's get it open and take a look. First thing that comes out here is a pack of metal clips, instructions, and then the fixture itself. Let's just check there's nothing else in that box. Nope. Which comes with a protective film. Let's whip the protective film off. Oh, it's got one of those little Chinese connectors, those very common eBay connectors, the little spring-loaded lighting ones that have the metal coming right up to the end. I'm not sure I'm overly thrilled about that. Okay, it comes with one of those connectors. Oh, and it's just got the cable coming out the back. I thought there might be a system for connecting it inside. Does this let you connect through from one end to the other? Let's I take it these don't. I think these screws come out. If they don't, I should actually test this beforehand, shouldn't I? Let's take these screws out and have a wee peek underneath and see what's inside. Nothing. So it doesn't have that loop-through facility. Well, that bit comes off. This lets us see what's inside. Can I get the reflector off here? Oh, the reflector. That is weird. The diffuser is moulded directly on one continuous moulding. That is a really clean line. How the heck do they do that? That kind of screws it up for getting what's inside. I can see down the end of it. I can see there's the LED strip down the end. No heat sinking as such, but it is spread. The dissipation is spread over a large aluminium panel in there. And will dissipate into the casing as well. Right, okay, that's not told me an awful lot here. Let's pop this back on. And we'll pop this back in, which kind of locks that in place. It looks as though it's had kind of been designed to be fed from either end, depending on the, or I suppose ultimately, that's just one standard plastic moulding, isn't it? Likewise, the standard sort of structure here, how does a clip work? Oh, the clip actually goes inside. That's odd. So the clip is invisible. It doesn't grip round the outside. It actually physically snaps inside. How do you get it back off again? I take it just brute force. Yes, brute force gets it back off. That's useful to know. Let's try this out. Let's stick it in the hoppy. So I shall bring up a new cable for this that I've just cobbled together. I could use the quick test, but I just happen to have this. Some of you will recognise it from a previous video. Not quite as safe as the quick test, but just quite handy to have around. So I just stuff a wire in there, stuff a wire in there. On the subject of this little connector, this knockoff Wago connector, which actually manages to produce something that Wago didn't actually even make. One of the things I didn't like about it when I opened it was that the springs seemed quite close to the top, the sort of border barrier between the connectors. I should mention, as others pointed out, that when you put a wire into it, that actually means the spring won't go up so high, so it does pull it further down. So it's not a bad connector. I like them. Let's bring in the flickery hoppy. Let's plug this in and see what we get. The light is actually it's a sort of, I would say it's not a cold white. It is the intermediate white. 20 watts dead on, well 20.3. Power factor is 0.55, so just barely above the 0.5. 149 milliamps for those who consider such things. It's very linear. That's quite nice. It's very bright. Oh, that is putting out a lot of light. Okay, let's take a look inside. Let's see if we can get the LED strip out of it. It does look like it's glued in, but that's not going to stop us, is it? So let's pop these little catches up here and put that out the way. That's quite novel, that they've got this clip that just clips in, and it doesn't clip in. It clips it, it holds it tightly, but it can be just pulled off. Useful to know. And if it ever just falls off, I suppose you could bend those out a little bit just to strengthen that. Let's pop this end off and see where the driver is. See if it's an on circuit board driver. Where is my screwdriver? There it is. It could be one of those little, although having said that, I didn't see any flicker on the camera. That's quite good. So that means it's maybe not one of the little simple current regulator and chip things. Oh. Let's prise this off with a driver. Oh. Not what I was expecting, actually. The driver here is a little loose circuit board that's just been glued in. The wires go straight onto the circuit board. The circuit board is purely glued from the other end. Now I wish I hadn't screwed that end on. Let's whip that back off. It's a very optimized design. It's based on the end cap being just two molded components like this, and then it's a standard extrusion with just holes punched. In fact, it's the screws don't even cut into those holes. They purely... Oh no, it actually goes through those holes and into the bottom bit here. Right, let's see if I can push this out, because it is glued from this end. Let's see if I can hoik that glue out of there. I would like to show you the inside here, but unfortunately, as I say, the... oh, that is really glued in quite tight. The reflector, the diffuser should I say, in the front is physically moulded in. That is not coming out. That is annoying. Why is it not coming out? Tell you what, I shall pause momentarily. This might be glued along its full length, not really sure, but I shall pause. I'll whip this out and we can take a closer look at it. I'll go and get the numbers off this and we can sort of reverse engineer it a wee bit and see what we can find. One moment, please. It has been taken apart, pictures have been taken. Let's explore the circuitry. So what I've done here, you may notice the text a bit back to front on this one. It's simply because I've flipped that image so the components correlate down to the circuit board. It's a single-sided circuit board and it's based around a BP2866B chip. It's a buck regulator basically. It doesn't have full isolation from the input to the output. That doesn't matter because it's a fully double insulated plastic fitting anyway. And it's interesting that the inductor is only anchored at this end. In fact, it's a bit of a shady solder joint there, but it doesn't really matter because when I was taking it out, thanks to the power of big globs of silicon, as I was taking it out, it bent that little inductor up and snapped a wire on it. It has been repaired now. It involved a microscope, not a microscope, it involved a very small magnifying glass in one hand while trying to hold the circuit board and solder onto that wire. But it is working again. This is good. We can do some tests on it. So let's take a look at the chip first. The chip is a BP Confidential Don't tell anybody, it's confidential. Freely downloadable on the internet, but confidential nonetheless. Let's zoom up on this and take a look at it. So the bare circuit they suggest for this is a incoming AC supply, bridge rectifier, smoothing capacitor, and the chip has it's got so little. It's got 1 sense resistor that's used to detect the current flowing in the inductor. So what actually happens is it turns on, and current initially flows when the transistor turns on in here. Current flows through the LEDs, and you get a voltage across that capacitor. That's important. It's it's charge a capacitor at the same time for extra smoothing. Flows through LEDs through the inductor, and then once it reaches a certain threshold, the inductor will turn off. The transistor in here will turn off, but the inductor, the magnetic field in it will collapse, and then this diode, is it called a freewheel diode? Then steers it so that it can use the current flowing through the inductor on both the charge and discharge of the magnetic field in it. The build up and collapse of the magnetic field, in my better description, is very simple, really. So incoming rectifier and capacitor provides a DC supply to it. It's got that inductor, diode, the string of LEDs, lots of LEDs, and I worked out that the voltage across this will measure it, but it's round about 120 volts, I'd guess. That's going to be quite precarious to voltage measure. That's okay. And that's more or less it. That little sense resistor, it's a very, very simple. It's one of the classic bright power chips. It's just optimized to make the design as simple as possible, and they succeed in that greatly. This one has a few extra features, being UK compliant. We've got the incoming supply is going to this side circuit board and this side. So one of them goes straight to the inductor. The other goes through this black thing here. This is actually a sleeved, well, I'm guessing it's a resistor. I've not actually measured that. Let's measure it. I'm going to guess that it's going to be round about 10 ohm maybe. 10 ohm fusible resistor. Let's find out what that is. Oops, let's see if I can get a connection on here. It's footery. Oh, it's actually a 4.7 ohm resistor, if that. So there is a resistor, and the purpose of the resistor is twofold. It limits the inrush current when you turn that on, particularly important if you've got lots of these, because they're all trying to charge that fairly juicy capacitor up when you turn it on. But it also acts as a fuse, and it's notable that that resistor has got an anti-tracking slot as well. Lots of anti-tracking slots here on the sort of primary side. That's quite good. The supply that goes through that resistor to the input to the bridge rectifier. The other side goes via an inductor for filtering, and the inductor's got a resistor across it. I think that's 5.1K. Let's measure that. Oh no, it's got an inductor. It's across an inductor. I won't be able to measure it because the inductor will be the factor here. I think this is to kind of limit the voltage across the inductor when it's dealing with significant spikes. For some reason they put a resistor across the inductors. I've never quite sussed that out. But that then goes to the rectifier. But also you'll notice there's two solder pads here. Therefore, or should I say there and there. There across the incoming supply, that's just a suppression capacitor. What value is that? That, I'm not going to be able to read the value of that unless I really just bend that down a little bit and get a magnifier in. 154, 150 nano? I think that's 150 nano. That's quite a high value. 150 nanofarad. But that's a little suppression capacitor across the input. The supply gets rectified by this surface mount bridge rectifier and then is straight across this big fat capacitor. It's a 6.8 microfarad 400 volt capacitor. They've got a couple of options here. They've got two pad options for a smaller or bigger capacitor, probably because this is probably the same circuit board that's used in the little short 300 millimeter one light as well, or it would be a universal circuit board. The sense resistor that I mentioned on the chip is here, but they've actually got two resistors in parallel so they can fine tune the value. So this says 1.6 ohms, 1R60, And this says 3R60, 3.6 ohms. So by combining the parallel resistance, they can fine tune the value and get the current absolutely perfect. There's the diode. There's the inductor, which is between these two pins. And there's the capacitor on the output, which is a value of, can I see that? It's 250 volt, 2.2 microfarad. But it will be running at fairly high frequency. It's probably a low ESR, low resistance. And it's also got a resistor across it, 304. My guess is that might be mainly, partly to provide a slight load, but also mainly to make sure the LEDs go out decisively instead of gently fading out when the power gets turned off. Very simple. The LEDs in the circuit board, there's a lot of them. There's 120 LEDs in this circuit board, but they're wired in sets of 3 in parallel. So if I was to, I don't know if you'd see that, but if I was to probe with my meter, I'm not sure. Well, let's see if we can actually do this. Let's put this to the continuity setting, and I shall shield this with my hand, and maybe you'll see the 3 LEDs at the beginning light up. Yes, you're seeing them light up. That's 3 in series, and then likewise, when you go along to the next one, if I can get a connection onto it, they're a set of 3 as well. So when you divide that down, it's 40 sets of 3, and if you work it out then, with 3 volts across each, 40 sets times 3 is going to be 120 volts across this. We can find that out, but I have to keep in mind here a couple of things. Well, the main thing I have to keep in mind here is that it's open. I don't want to short it and damage it. But this circuit board should be treated as being live at mains voltage while this is out, because the circuitry isn't isolated from the mains. It's just the simplest way of doing it. It keeps the costs down. It means the transformer is very, very simple, since it's not really a transformer, it's an inductor. So I'm going to bring in the quick test this time, because I want to be able to isolate it locally. And then I'm going to try and probe that gingerly with a meter. So let's bring the meter in. Let's set the meter to DC voltage. Let's set it to about 200 volts. I shall stick these leads into the Cliff quick test. And then I'm going to be very careful about making sure that nothing can touch anything else here, because this is bad news for electronic circuitry if I short anything out. So I'm going to turn this on. It should light now that I've fixed it. Hopefully it has lit. Are you going to be able to read this meter? I'm not going to be able to read this meter. I'm looking at lights right now. Let's probe there. And there. 117 volts, pretty close to the 120 volts I guessed. Let's do a current test now. So let's pull this wire out here. Let's get a little clamp meter in, the one that can measure DC, the Unity UT210E. It's a nice little meter. Very, very handy. Let's select DC, let's zero that out, DC current, make sure nothing's touching this circuit board that could be grounded, plug it in. It shows about 150 milliamps. It shows 157 milliamps. Let's null that out again. Let's standardize about 150 milliamps, I think I'd say that is. So that was roughly 120 volts times 150 milliamps, 18 watts. It's fairly efficient. That's pretty good. It also means that each LED is passing, because there are 3 LEDs in parallel on 150 milliamps, each LED is passing 50 milliamps. And the voltage across LED is 3 volts times 0.05, which is the 50 milliamps, equals 150 milliwatts. That's not too bad for these LEDs. They're modern LEDs designed for lighting applications. They're designed to handle a bit of heat and last a long time, and if they are the Samsung LEDs, that does inspire a bit of confidence. Oh, there is one other thing I wanted to mention. The moulding. I just doodled it here. It's quite clever. It's such a long moulding I can't really show you end on. But the diffusion bit, I'm going to have to actually take a look at it now. Yeah, that's about right. It maybe comes up a bit closer. So the plastic in the front, it's solid white here, but this bit here, where the light comes out, is translucent, but it's an absolutely seamless transition, but you can't peel it off as such. It is rock solid on that. And the extrusion is designed so that it grips the circuit board. The circuit board literally slides in. Everything is held together in glue, with glue in this, which is just the way modern lights are done. So the driver is glued in. The cable is interesting as well, but the circuit board slides in. It doesn't make a thermal contact. It is just an aluminium strip that runs along. And at the end of that, you can see a little trace of it on here is the glue, because they just literally just slid it in and then smeared some glue in the end just to actually hold this in place. Everything is glued together. The cord restraint is notable, that you feed the cord through like this, through a hole, and then it literally just bends down and gets jammed in the plastic housing here, and it closes and it grips it to make a cord restraint. It's very effective, it's very functional. What else is worth mentioning? This stops just short of the depth that these go to, so these provide a nice flat surface, whereas the clips, when it clips on, this allows for the clips going like this. They sort of go in like that. Oh, that wasn't very good, but not to worry, I've done it. So the clip goes in like that. It allows the room for the screws between there and there. And when you clip it on, theoretically, that thing should then be completely flush to whatever surface you put it on. It's very neat, very optimized. It is a mass-produced light, ultimately. So it's quite neat. It produces tons of light. It doesn't have any flicker due to the two layers of smoothing, the input smoothing and then the output smoothing here. It is relatively serviceable to people like us. If the capacitors gave problems, I would say if you ever do try opening it, be careful about the fact that this inductor is not glued down. I'd like to have seen that. I'd like to have seen during manufacture a little dot of glue put at the other end of the inductor to stop it hinging up like that. It makes me think that during shipping the vibration could actually affect that. But it seems relatively nicely designed. It seems functional. The 20 watts, this strip is going to get pretty hot, but then again, it's modern LEDs. They are designed to run quite hot. Not sure what temperature we'll get up to. I suppose that depends on the environment you're operating in. So there we have it. That's I'll provide a link to this light down below just in case you're interested if you live in the UK. And that's fundamentally it. It's a neat, modern alternative to fluorescent lights. You know what? Now I'm thinking about this. There's a place in Douglas in Isle of Man. Douglas is the main sort of town, and it's the place called the Villa Marina, and they recently changed the lights in their toilets to something that looks just like these strips. I wonder if that's what they are. Because the original lights were recessed, fluorescent, were really dull. It was always really dark. They put in a small number of these, really impressively small. They put sort of MDF wood up over where the existing recess fittings had been, and they screwed a row of these in the front. And I have to say, the output of them, they'd chosen the very cold white, and it gives it a very clinical look. But the output is stellar, and those ones in particular, if they are even closely related to these ones, they've been lit for long hours for about a year now. So they are pretty good. They're lasting well. So yeah, the future of linear LED lighting, I guess. And it's pretty neat. Very smart indeed.